Welcome back to the Free Ballin Club. So for those of you that are listening to the podcast version of this, you can just go to YouTube and search for the Free Ballin Club, Free Ballin with an apostrophe, no G. And you can find this video and all the visual representation that I'm going to be showing. In this episode, I'll be talking about the concept of what if. So I'm not exactly sure how many what if questions I'm going to get through, but the first what if question we'll start with is, what if Atlantis existed and how do we know? So the first that we hear of Atlantis is from Plato. And there's a few things that kind of give us a timeline as far as when Atlantis would have existed. And you can look at other videos on YouTube and you can Google it and you're going to get about the same idea, about 12,000 years ago. And I'll show you why. So Plato, it's about 429 BCE. So 2,400 years ago is when Plato would have been on the planet and live and breathing. So now, whenever we look at Plato's description, so he talks about Solon, which we are told the story on his travels in Egypt, specifically by the scholars at Sais, and had meant to put it into writing but never found the opportunity. Fast forward, Egyptian priests, 9,000 years before Plato. So right now, we're at 2400 BCE. Add 9,000 years to that, and we're looking at 11,000 years ago. 11,500 years ago, almost. So, if I was to just Google notable theories about the lost civilization of Atlantis, one of the most according to Hapgood, around 12,000 years ago. Night and day into the ocean around 9600 BCE. So we're 2019, so that's almost 11,600 years ago. So we're looking at Atlantis existing around 11,000 years ago. But it talks about how Atlantis likewise sank below the sea and disappeared. Now, there's theories about what that could have happened. It could have been tsunamis. It could have been, a cataclysmic impact or whatever. But one of the things that just recently came up in 2019, a couple months ago, was a group of scientists found a crater under the Greenland ice caps. And they estimated that to be about 31 kilometers. Now, for comparison, you can see that the crater on the Yucatan Peninsula, Chicxulub crater, I don't know if I pronounced that right, was 200 kilometers wide. And that's what they believe killed the dinosaurs. The Chesapeake Bay crater is 85 kilometers, and then the Hiawatha crater, which is the one that they found in Greenland, is about 31 kilometers wide. And notice right here where it says that the Hawaii crater was somewhere between 100,000 years ago and 12,800 years ago. Oddly coincidental to about the time that Atlantis would have disappeared. And this is where the Hiawatha crater is. It's in the northwestern side of Greenland, under the ice caps. And if you look, you don't know what the Younger Dryas period is. The Younger Dryas period was a period of rapid cooling in the late Pleistocene, 12,800 years ago to 11,500 years ago. So this was followed closely on the heels of a dramatic, abrupt warming that brought the last ice age to a close. Now, I just want to stop right here, because this part right here is not completely accurate. This is, technically, we're still in an ice age. And right here, scientists have known for some time that Earth goes through cycles of climatic change. The results is a long-term period of glaciation, what is more colloquially known as an ice age. So notice right here it says, by definition, we are still in the last great ice age, which began during the late Pliocene epoch 2.58 million years ago, and are currently in an interglacial period, which is a warming period. So technically, we're still in an ice age. So I just wanted to make that distinction. So moving forward, this is what the Younger Dryas looked like. About 13 to 14,000 years ago, there was a dramatic drop in temperature. And then there was a brief warming period, and then a brief cooling period, and then it warmed up rapidly. About 12, 10, 11, 12. So yeah, about 12,000 to 12,500 years. It just rose, temperatures rose. That's almost 1,000 years. So this Younger Dryas period happened around the time 12,000 years ago. And there is evidence of this Younger Dryas period of being something of a cataclysmic event that caused all this. So if we look down here, but notice that it says, in an attempt to save the Kroll-Milankovic theory, Brocker and Denton published a paper postulating that large amounts of fresh water discharged into the North Atlantic about 12,800 years ago, when the retreat of the Laurentide ice sheet allowed drainage of the glacial lake Agassiz to spill eastward into the Atlantic Ocean. They proposed that this large influx of fresh water might have stopped the formation of descending higher density water in North Atlantic, thereby interrupting deep water currents that distribute large amounts of heat globally, initiating a short-term return to glacial conditions. We have what we call the Younger Dryas boundary layer. And this boundary layer covers Canada, North America, well, Canada is North America, Canada, United States, Mexico, the northern part of South America, Europe, and parts of the Middle East. This field is of a black layer that looks something like this. So this black layer found in all these places. And it's basically a black layer. You can see it right here. That is nanodiamonds, melted glass, carbon, and all of these are indications of either a volcanic eruption or a cataclysmic event, like a meteorite or something that would have to generate large amounts of heat to create this melted glass and these nanodiamonds. Now, as you notice here, this is a paper that was written from the University of Chicago, and you'll notice major cosmic impact event has been proposed at the onset of the Younger Dryas cooling episode at approximately 12,800 years ago, plus or minus 150 years. Observed Nd polytypes include cubic diamonds, lonsdaleite-like crystals, and diamond-like carbon nanoparticles called N-diamond and I-carbon. So these were found, this is basically what their Younger Dryas layer, boundary layer, consisted of. Small nanodiamonds, carbon, which the carbon gives it the black color. So there's strong evidence that the Younger Dryas period was right around the time of some cataclysmic event. Notice that these are all spots where this boundary was taken. These places that were surveyed, and that's where they found the same layer. So the Laurentide ice sheet is talking about the retreat of the Laurentide ice sheet allowed drainage of glacial lake, and this was about 12,800 years ago. Now, when we look at the Hiawatha crater that was found in Greenland, that happened sometime between 100,000 and 12,800 years ago, it is right here in Greenland, the northwestern tip of Greenland. And then if we look at the Laurentide ice sheet 15,000 years ago, right here is where that crater would have hit, or where that meteorite would have left that crater. Right here in the Laurentide ice shelf. So, the other thing is that somewhere in the Pliocene, between 40,000 and 10,000 years ago, America lost over 50% of its large mammal species. 12,800 years ago is right in the middle. Well, not in the middle, but it is right in between 40,000 and 10,000 years ago. So, a meteorite impact could have completely wiped out all those mammals, especially if it hit in Greenland. It would have been close enough that they're gone. Now, the Hiawatha crater was... So, if we look here, based on the size of the crater, the team estimates that the asteroid would have been around 3/4 of a mile across and would have weighed 11 to 12 billion tons as it entered the atmosphere. This would suggest that the impact happened sometime before the end of the Pliocene epoch, around 11,700 years ago. The impact could have caused massive wildfires across much of the continent that in turn led to the extinction of many large Ice Age animals like mammoths and mastodons, as well as the human Clovis culture. So now, with all of this being said, if we take into account that there's a meteorite crater in Greenland that could have released large amounts of water, then we see that this could have also probably created some type of tsunami or something like that. So if Atlantis, which is claimed to be in the Atlantic Ocean, would have been in the Atlantic Ocean when this meteorite hit, which the times line up, then this meteorite could have been what destroyed Atlantis. Whether it was with the tsunamis, the rise in ocean levels, rapid warming, whatever the case may be. And here's the other thing too. So we'll probably go into this a little bit deeper into future episodes. But a lot of different cultures have a story about a global flood. Now, a meteorite was to hit in the Atlantic Ocean, or close to the Atlantic Ocean, would have sent tsunamis everywhere. But where this crater is, it's under ice. So if you remember, we're still technically in an ice age. So if this meteorite would have hit that ice shelf, weighing 11 to 1200 or 11 to 12 billion tons, that would have sent a lot of ice in the form of water, vapor, water into the atmosphere, which very well could have created a flood. I mean, all of that water vapor going into the atmosphere, I mean, who's to say that it couldn't have rained 40 days and 40 nights with all that ice and water in the atmosphere? So I think I'll end this episode here. I was planning on doing a few others, but I'm just going to end it here. If you guys, like this topic and you want us to go a little bit deeper, shoot us some comments, let us know. And we'll put together a deeper episode where we talk about this a whole lot more. If you have any other ideas, or you think we got something wrong, or you have other theories, let us know. Like us,